Welcome everybody, we'll be starting in a moment. Okay everyone, thanks for waiting. We'll be starting now. So we're just picking up from yesterday. We're gonna try to fix this memory bug. As you can see, the pointer is garbage. Not sure how it happened, but we're gonna try to figure that out. It's incredibly odd, right? I did think maybe we pushed a bad pointer to this thing, but I've already ruled that out, so it means the memory vector was corrupted at some point. Okay, we're gonna keep track of the pointers because we disabled free to make this easier to debug, so you can't free memory anymore. Purposeful decision. So that pointer address should stay the same for every time we launch the operating system. So we're gonna try to watch it, see when it gets changed. I'm not sure if the hardware watch points will work in the kernel debugger. I've not had to use them before actually, so we'll see what happens. But we'll just put some breakpoints around just in case, so we don't waste our time. That's so funny. Yeah, I enjoy it. It's great fun. Good life. So we need a break on the creation of the graphics, along with the window redraw. I just have to wait a minute or two now. Yeah, I agree. I agree. You definitely get you think better when in terms of abstraction, the more challenges I think that's with anything in life, no matter what you're learning. So it's incredibly slow at the moment. I think it's to do with the QEMU machine type I've used. But I've had to use that machine type because we still have some legacy hardware drivers in the kernel. But it's very slow, right? I need to try to improve that. Okay, let's step through it. So this close button stuff is a little bit of a hack, right? Because we're in the kernel, obviously I don't want to make a full-on graphics SDK in the kernel. That doesn't make sense, right? But at the same time, I didn't want the close button to be a part of the user space. So I kind of just put in a little bit of a hack here, right? That's the only button element you'll ever find in the kernel, just the close button, that's it. The rest has to be done in the user space, which I think makes sense. So those CSS levers, you'll know what a z-index is. Makes something go above another element. We have it with windows as well, right? Because if you drag a window over another window, obviously that window should be drawn last, right? So it shows to you first. There's our window drawn. So we'll keep stepping through and see if we can find the bug. What? You didn't have to give me anything. Thanks so much. Really appreciate that. So kind. Okay, so the user space has successfully created the window. So we'll continue now to the next breakpoint. Now this is a very important function because this is where the graphics is created that gets corrupted, right? So we need to be careful with this one. Now the addresses don't match, so that's very interesting. It's not this one, it's the one we're about to create. Okay, watch points to work. Brilliant. Let's see where we're writing. Okay, that's absolutely crazy, actually. Um, Starting to understand what might have happened. So we're in the user space application, and in the kernel, we actually try to write to that memory, which means we're passing some vector that's in user space into kernel space. And that's obviously a mistake, right? Something's gone wrong, but that might explain why there's some issues here. So let's try to understand this. So GUI element create. Let's go to there. So yeah, I can see it. We push into that vector, which is correct. But that's only supposed to be for user space. So I think somehow that pointer's being passed to the kernel, which should have never been allowed, right? That should have never happened. So I'm only streaming on YouTube at the moment. And yeah, we can buy a copy here for that price too. Thank you for that. Um, I'm only streaming on YouTube at the moment. And is kernel development and embedded development similar? That's an interesting question. But you generally work with less bytes in embedded development, but at the same time, it's very low level because you do communicate with the kernel a lot of the time if you're writing embedded devices, right? So yeah, I would say that if you have the skills to write embedded software, you're going to be much more capable of building a kernel. But are they the same? No, absolutely not. But they're very similar, and they're very similar skill sets as well. So if you can do one, you can probably do the other. So I do have a course in the description that teaches you how to make kernels, by the way, if you're interested. Okay, let's continue and see if we hit another breakpoint now. Okay, so it looks like it's corrupted in the user space, not in the kernel space. All right, let's keep checking this. What's my opinion on AI? Well, it's going to take all our jobs. I know I know that most programmers don't agree with me, but yeah, I think it's coming for all of us. Yeah, I've definitely experienced a reduction in students since this AI, and I don't think any job is safe if it can be done digitally. I don't think it's going to happen overnight, but I think it's coming for all of us. So this is the userland SDK, guys. It's linked by user programs, right? It's not kernel code. Graph display relative creates a graphical instance on the kernel to be used in user space, but it doesn't expose the pointers of the actual true graphic on the kernel. Yeah, there may be some human positions, but like we're talking like a team of 40 developers becoming 2 or 3 developers, which just oversee the systems. I I believe that's going to happen, but I know most people don't agree with me. But we'll see what happens. I hope they're right, to be honest. I do wonder if we actually put the watch point on the correct address after all, because this is a it's not, it doesn't look like the same memory. But I don't know. I guess it must be right because it's still a vector thing, and what are the chances of that memory happening to be a different vector? So yeah, no, it probably is. But that's not a graphical vector. That's a graphical. That's the GUI elements. So maybe somehow we pass some user vector into kernel space, but that doesn't make much sense. All right, so it's line 144. We need to pay attention there. So this has something to do with the elements vector, which would have been created with Windows graphics. All right, let's head over to the kernel side responsible for giving you the Windows graphics. The Linux kernel, I don't contribute to the Linux kernel. This kernel is my own kernel from scratch. So you see, the idea is we return these userlang pointers, right? That can only be accessed from user space, and the kernel stuff's still isolated. But yeah, maybe somehow they were able to change that pointer. And I don't think we rely on that pointer representation either. I think we pull it. Let me double check that though. I think I found one of the bugs, guys. I think we're using a different type here. Ah, no, we're not. Yeah, so that's what we do, right? We pass the userland pointer into the kernel, but because it doesn't trust it, right? And then it will try to check if that actually is registered with us. And if it's not, then no gets returned. Yeah, no, it's following the correct rules. And we call process userland pointer create, which registers the pointer in the kernel basically, so it can be used. These things are important because it stops like a process passing kernel pointers that it has no access to, and then manipulating the kernel, right? So by registering the pointers on a per process basis, we solve that security hole. I've been working on this kernel for 5 years now, but it's based on the kernel development course I built, the part one course, in the video description. And this is the part two video course, so you'll be able to make all of this stuff when I'm done building it. The part two course I've been working on for about a year now, I guess, maybe a little short of that. So we'll get this done, and then I'll release a part two teaching you how to make all of this Windows stuff. I mean, that looks fine to me, to be honest. So this maps the pixel array into the user process so they can manipulate the pixels on the kernel. But it's safe because it's all page aligned, right? So we can control what the user space sees. Maybe my past self left me this warning. Maybe this is the problem. All right, let's just test for that. We're going to disable the freeing in the actual process as well. All right, so there we are. Now we can't free anything anymore. We'll rule out whether that was the cause. All right, we're going to build this in step third again. I guess it doesn't feel like 5 years of work. But I mean, it's not 5 years all the time, right? I mean, I made the first part of the course 5 years ago, but yeah, it does take a long time to make them. Like I've been working on this part two course now every day for the past 9 months, and that's like over 5, 6 hours a day, right? That's why the prices are quite higher than your usual courses you find online, because there's significant investment involved. The longest course was a comparative element course that took me 1 year and a half working every single day to build that. That's why it used to be priced very high. It's a little lower in price now. So let's start by breaking on graphics create. Give us a sec, guys. Okay, nice. We can work with this now. All right, we're back in the user program code now. So this is line 144, right? So this is the vector we were concerned about. Let's check it. It's definitely not that address. Oh wait, it's the memory, isn't it? I think. Let me step through it first. Yeah, this is definitely the memory that was corrupted, right? I'm sure that address is correct. Won't allow me to go into the source code view, so I have to do it in assembly for a bit. Okay, perfect. Wait a minute, is that the same pointer? Right, okay. It's not the same pointer, we're good. No way, it's the same pointer, guys. I'm sure of it. Let's check again. Hold on. Ah, no, no, no. It's just a slight difference. A slight difference. We're okay, right? Okay, because I thought we were having the same pointer then. That would have been a problem. Okay, it's slightly different. That's fine. Take care, everybody who's leaving. Thank you. Uh, we'll continue here. Feel free to watch tomorrow when I'm done. All right, let's continue. Just give me a second, guys, because the browser's messing up. The one that shows me the YouTube comments. Just refresh the page. You can't see this bit. Hold on. Okay, I'm back. Yeah, Perkele, or however you pronounce it, your name. The JDB it makes sense in kernel development. I couldn't imagine using an IDE dealing with all of this like that. I have to switch between multiple windows constantly, and sometimes I have to debug different programs at the same time, adding different types of symbol files. I think an IDE would make it more problematic. I mean, I'm sure people do it, but it's much easier in the terminal for me with this type of debugging. All right, so we know the address we're working with. That's what matters. And you know what? It's not even a graphical vector. It's a vector of GUI elements. It's not a vector of graphics info. So I have no idea how that pointer somehow ended up in the vector of graphics info. That's crazy. It's no wonder we've been having crashes. Give me a second, guys, while I think about this. All right, okay, let's continue. Okay, the heap address actually did change. Okay, that's odd, that, because we removed all the free, so it shouldn't have changed. Unless I changed something, but I don't think I changed anything. Hmm. That makes things more complicated now. If the addresses don't remain the same, we can't rely on the watch points. It's probably something so stupid as well, like forgetting to put an ampersand or something. It's probably something so silly. Right, I'll be right back in a few minutes. I'm gonna make a cup of tea. I didn't ban anybody from the stream. Ah, you're talking about search engine, right? I get it. Right, I'm back now, guys. Cool. But that was worth a check. I wanted to see if somehow the GUI element ended up in the vector. Doesn't appear that way. Oh, we're going to try the watch point one more time, but we're not going to rebuild the project because I don't want to give an opportunity for the pointers to change. GUI wasn't a valid address, really. I'll look out for it then. Um, Sometimes JDB doesn't show the addresses properly until you actually get into a scope. So that might have been what you noticed, but we'll check it anyway. Thanks for letting me know. Okay, so far the GUI is a valid address, but we'll keep an eye on it in case anything changes. Maybe the GUI in an element might have been wrong. We'll keep an eye on it. And null is allowed for the vector memory, by the way. We only allocate the memory when an element is added. You see, that might have been what you saw because the addresses can look differently before you enter the scope, right? So the true value is the same there. Let's just step into the kernel as well. We're going to really try our best now to find out exactly what's causing this. Okay, so we're writing into that memory now, so we need to be really careful because this is the memory that's causing problems later on. C++ developer could write a kernel quite well, with a bit of work they can do it. Yeah, I mean assembly helps. You do need to know assembly language to write kernels, but in my part 1 course, we still have some catch-up sections that teach you some assembler anyway. which you can find in the video description, the part 1 course. Yeah, C++ development, you already got a lot of the skills, because if you know C++, then it wouldn't be too difficult to use C. So yeah, all good. Assembly would be your biggest obstacle, I suppose. And my chat tab crashed, guys, so just give me a second so I can get the chat back up. Hold on. It's surprisingly quite buggy, the YouTube streaming stuff. Okay, nice. I see it again. Thanks for your patience with that. So that is where the vector that causes issues later on exists. Okay, that's where it was first existing. Line 311. That's where we're first writing into that memory that later gets corrupted. And you know, I think this is exactly where it's happening, guys. Because that source pointer does not look normal to me. Something really odd about that. That does not look right. No, that's okay, guys. It's stack memory. It's stack memory. That's why. That's why it looks so strange. Okay, we're fine with that. You can see the stack pointer looks very similar. It's all good. But it also looks a little similar to the type of values that were put into the vector, right? Yeah, it's unusual. I wouldn't set up the kernel like that, like it's a web application or something. It doesn't make sense. No, it's best to write the kernel in C and then write a C++ wrapper on any libraries you might have. It just makes more sense in my opinion. Um, the problem is if you're using C++ in the kernel, you're just anything available that's in C that's public, it's not going to work very well. It just makes a lot more sense to write the kernel in C and then put wrappers over things. That's how I would do it if I really wanted to use C++. So you know what? This is actually wrong, actually. I think so. Ah, no, 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 it's not. It's not wrong. It's not wrong because we're copying from the source pointer, which is the stack. So we should be able to just cast directly into the source. Let me try that just to make sure we're seeing the correct element. Yeah, and we can cast directly into the source, so it's not a problem. I don't think so. Let's check the actual pointer of that. Yeah, normal. Very normal. So this copy is correct. And we can see at this point in time, the memory is not corrupted. Not corrupted, guys. So that's good news. So we can write a little comment for that. Okay, we've written to that memory again, guys. We're writing there right now. Let's try and find out where that's happening. Oh my God. It's an overflow. We're buffer overflowing into different memory. That's what it looks like to me. It's probably something to do with the pixels pointer that was returned to us. Let's try and understand this a bit more. That doesn't make sense how that's happening. So let's try and understand it. I can't remember where we left that address comment that tells us what the actual address was. Ah, there it is. Okay, good, good. So where are we right now? Let's try and understand that. We're in the draw pixel function, user space. Okay. And where is the memory where we first push? It's here, line 311 in the kernel. So it's on the parent's children. And we correctly push into there. So this actually belongs to the to the to the to the graphics information, not the pixels vector. So what's happening, guys? We're overflowing a buffer and somehow corrupting the kernel data, which we shouldn't even have access to, right? It's probably something to do with the mapping. Okay, I'll be back in a moment. At least we're finding what's going on now. That's really good. I'm back, and hello, Umesh. Yeah, so this pixels buffer should have never been. I mean, this graphics memory should have never been writable. It should have caused a page fault. So somewhere in the code, I've incorrectly given a page user space access because it should have never happened, right? This buffer overflow would have never happened if the pages were set up right. So we'll need to check what's going on with that when I fix this bug. Just give me a second, guys. All right, let's get on with that. We can literally see the corruption happening in front of us. So we're essentially writing pixels over a graphical entity that is not pixels. And yeah, not good. And we have a -1 for length, really? That can't be right. All right, well, we found the problem. That's perfect. We need to make a note of that so I don't forget. All right, nice. That note will remind me now in case I forget later on. So this may have been the problem. I assume we'd be checking during creation the absolute positioning, and therefore I just rely on the relative check because naturally the absolute will be correct if the relative's correct as long as the absolute is checked somewhere else. Maybe we didn't perform that check somewhere else, and I assume we did, resulting in a return of true. To pass the bounds check, incorrectly calculated the true x and y position, pulled a pointer, but made a pointer to the wrong memory, did a mem copy, corrupted our graphics information children, and then the kernel crashed. So that's what's happened, guys. Crazy, 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 crazy. So let's try and fix the mapping problem first, because user space shouldn't even be able to do something like this anyway. So let's fix the page problem that resulted in the user space being able to write to kernel memory, and then we can fix this issue. Yeah, and although it doesn't look exact because the graphics info on the user land symbols is different from the one on the kernel symbols, although it doesn't look exact, you can see it looks very similar to the corrupted memory we had in the kernel. So this is definitely the issue, 100%. So we need to figure out the pointer that's returned here and how it's returned, and then we'll be able to solve this problem. Okay, so it is width and height. I just wanted to be sure of that. So the pixels width is width and height. That's the size that should be. So that's fine. Ah, but wait a minute. We're not including the size of the frame buffer pixel. So we're mapping under the amount that we need. So yeah, that's not good. All right, that should be the correct size now, I think. It's just a training kernel to teach people kernel development. You can see the part 1 course in the video description if you're interested. What I'm doing here is for the part 2 course, which will be released soon in a few months. I left a little note for myself on a security concern, so we'll patch that later, I guess. Well, that looks like a bug to me by there. Yeah, I think it is. Yeah, because in a previous, I decided a couple of weeks ago how I was going to do it is rather than just map the physical address to the virtual address, um, that could be problematic because if we later free one of those pointers, the kernel or the user space will maintain their copy still. So the solution I thought of is okay, rather than map the virtual address directly to the physical address, we'll allocate enough memory in the user process for the whole pixel size, and then we'll map that virtual memory to the physical pointer. And what this means is then the user space application, there won't be any collisions. So the current implementation is not doing that. It's grabbing the current address from the page tables, and then it's mapping us to that. And that's probably why we're corrupting the graphics info memory. So we're going to fix that, and I think our bug will go away. Give me a second, guys. All right. And by doing that, we actually fixed that security concern with the warning I left myself. All right, I think we just solved that bug, guys. So in summary, what I think was going on is we essentially are uh, grabbing whatever the physical address was pointing to, and then mapping our virtual space to that. And this particular case, it looked like the page tables were pointing to the graphics info memory, So then when we returned that pixels vector to the user space and it wrote a pixel, it was actually overriding the graphics information memory. So that's what I think was happening, but we won't know that until I test it again. So let's test it. Yeah, and you can too with my course. Check the video description. Teach you how to build a kernel from scratch. All right, let's get that debugger on. And please subscribe, guys, because it helps me helps keep me motivated to keep making more videos like this. We're just waiting for this breakpoint to come. Ah, there it is. Perfect. Let's step through and see if the bug is solved. Bug has been solved. Look at that. No more corrupted pointers. It was a mapping issue. Perfect. Took me about 8 hours to solve that, guys. Crazy. Maybe about 5. I don't know. It's too long. And look at that magic. Do you see that peach square? It's working. Now let's restore the old button functionality and see if it actually draws the button now. Okay, because I stripped it all down when I was trying to fix this bug. So we're going to put it back to where it was and see if the button actually draws properly. The bug was essentially that what were we doing? We mapped the pixels incorrectly into the user space. We were supposed to map only the pixel memory, but we mistakenly mapped the memory of a graphics information entity. And this resulted in the vector getting overwritten by the user space, which should have never happened. So the solution was to make sure we allocate enough memory for the user space application pixels, and then we mapped that to the physical one, and that solved the bug, right? Because then there was enough memory for it to use. Whereas the old implementation, rather than allocate memory, it would map to a kernel address, thinking it would stay that same, right? Thinking it would stay the same. And the address it actually mapped to was the graphics information, which was not even the pixels. So by allocating that memory and remapping, we solved that issue. All right, everything looks fine. Let's test it. And now we wait and see if it worked. Now it's the first time I'm actually testing this button code since the bug's been solved, so it might not work, but we'll see. And there we go, it worked. I mean, it's a really bad button, right? I mean, it looks awful, but it works. So yeah, that's cool, right? We've got a button there. You can't click it yet. I still need to make the code for that. And obviously, now that I can see how bad that looks, I'm gonna center the text. So the centering will be really easy, right? It's just divide by 2, simple. So we'll center that text soon. All right, guys. Well, it's 5 o'clock here now, so I have to go. But we'll pick up on this tomorrow, where we'll implement those buttons properly.